Hi, hello everyone, and welcome to our webinar, Lakehouse, the foundation for your AI strategy. I'm Roxana, and together with my colleague Teodor Dimake, we are so happy to have you here today, and we will just take 2 or 3 more minutes for everyone to join, and then we are ready to start. Theo, are you ready?
Yes, another good day for another good webinar.
What's the thing that you are the most excited about this webinar?
It's my favorite topic, data. I could talk for hours about it.
Well, we have 1 hour, so
Let's make the most of it. And I'm also curious about people's questions. I always find that I learn something new myself about what the others are doing and what they're thinking. So it's always cool to get feedback.
it's a good indicator indeed.
Mhm.
I see that we are slowly gathering. Just more minutes and we will get the ball rolling.
How about you, Roxana? You're always on the road.
Yes. But today I'm in Bucharest enjoying the sun. Finally.
Yeah, finally.
Okay. So I think that we are ready to start. Again, hello everyone, and welcome to our webinar for the second one this month. I'm very excited because we are starting to be more and more present. And the topic for today is Lakehouse, the foundation for your AI strategy. I'm Roxana Stăneiu, Head of Growth in Minded, and together with Theo Dimake, who is our Technical and Business Development Director, we are going to walk you through why the Lakehouse is one of the most important aspects when it comes to building your AI strategy.
Welcome,
Okay.
everyone.
And Theo, if you can go to the second slide, because we would like to start with a little surprise for you. So, you will get a chance, if you stay until the end, to be among the winners of a free webinar on AI and automation for business. And we will announce the winners next week. So hopefully one of you will be among the ones that will benefit from the webinar, and it will be a hands-on session on how to integrate AI and automation to boost efficiency. We are very excited to offer this for you. And again, we will announce the winners next week. And fingers crossed to be one of you.
This
And
brings back memories about sweepstakes.
of course, and it's always good to start with the surprise. And before letting Chio speak about the most interesting part and the hands-on discussion on the data lake, I would like to quickly give you an overview of Minded, who we are and what do we do. So Minded is a software development company that was founded 10 years ago in Bucharest, in Romania, and we are very happy that we just had our 10-year anniversary, a big party over the weekend. So initially we started as a Java house, but we have been lucky enough from the very beginning to work with the big enterprise customers in retail, and then slowly year and year we grew And right now, we are technological partners for one of the biggest retail companies in the whole world. We have four development centers across Romania in Bucharest, Sibiu, Cluj, and Iași, and of course, two business development centers in Frankfurt and Zurich, and over 250 software engineers. We are proud to expand our services towards digital transformation, and of course, data has been a very important pillar for us since the very beginning. And since 2018, we have been investing quite a lot in working with AI. And of course, in the past few years, since the appearance of generative AI, we expanded our portfolios in that as well. And we are extremely grateful to be together with our customers when it comes to the whole product lifecycle, from the ideation to prototyping to, of course, development and maintenance and support, and being together with them in order to generate business value and bridging it with the latest technology available. We are Databricks partners and also Microsoft partners in the process of becoming proud SAP partners. And we truly believe that everything we do at its core, there are the people. We are working in a people's business, and everything we do is centered around the people that we are working with, the people that we are building relationships with in the forms of our customers, and the people, of course, that are benefiting from the software that we are building. So today we are going to double down on the data part, one of our most important pillars inside our company, and I would like to invite Theo to start the journey of today.
Thank you, Roxana, and welcome everyone. Also, those of you who join later, this is where our story begins. And I want to start by asking, and I've done this before with a live audience. It's always harder in a virtual session, but I want you to ask yourselves and think about and raise your hand virtually if you can. If you heard the phrase "data is the new oil," and I expect that many of you have heard of this expression. And what I usually do with a live audience, I ask them to now keep your hands raised if you have successfully refined this oil into fuel for your business. And what I usually find with a live audience is that not many hands are left raised after that question. And this is what we will explore today. And why is it tied to AI? It's because AI is a hungry machine, and we are on the verge of a revolution in the way we handle data. And this is compounded and driven and accelerated by the needs of data in the AI field, especially with bigger and better models like the GPT-4s, like the Claude 3, more recently Claude 4, the Geminis, and so on. And today I want to give you a glimpse and some inspiration maybe on how this data refinement can work. But first, let's try to understand, what the usual pain points, the usual suspects around data are. So these problems come in different sizes, and usually these problems have to do with volume, velocity, variety. They have to do with quality and consistency. They have to do with the fact that data lives in silos many times, and the lack of expertise, the lack of skill set to process this data. The problem with volume and velocity and variety. So think about that every day your business generates data, and this is the picture that I generated with the help of AI. Your business generates data equivalent to a stack of books as high as the Eiffel Tower. And for bigger companies out there, this is actually indeed the case. But how many of those books have you actually read or understood? So the problem is that data grows at a rapid pace, and it's either too much or too fast or too different. So this is one of the major points of having to deal with data. The quality and consistency side, you not only have to find a needle in the haystack, you also need to find the right needle. Many businesses struggle with dirty or irrelevant data, and they need to cut out the fluff and find the nugget of gold. Then there are these data silos, and it's like there are many data silos around the organization, and usually data is structured around the organization. So imagine trying to complete a puzzle when each department holds on to a piece and won't share. And data often lives in these department silos, and making it difficult to get a comprehensive view. And the skill gap is all about, and I like to use analogy. So maybe think of owning a restaurant, and you have the raw ingredients in a kitchen but no chef to cook it. And many organizations struggle with recruiting the right talent and the right team structure and building the right data-driven organization, the right data-driven culture. Because having data is like owning a library, but if no one reads the books, what's the point? So the thing about data culture is that many businesses struggle to foster a culture where decision making is truly guided by data rather than intuition, rather than the gut feeling. And yeah, this is where employees might resist change. They lack trust in data or simply do not know how to interpret it effectively. Let's uh, let's have a look at what, we just talked about many things which are overwhelming, right? But this overwhelming side of things also brings opportunities. And I want to just briefly touch the subject about Roxana, you wanted to say something about?
I have a curiosity, Theo,
Sure.
because I'm mostly interested in the volume, velocity, and variety part.
Okay.
It seems that it's something that really brings quite a lot of chaos in the organizations.
Mm-hmm.
And based on your experience, which one of these three V's, so variety, velocity, and volume, cause the most friction when it comes to raw data?
That's a trick question. And the answer is it depends.
Of
Many
course,
times the answer is
it
depends.
depends.
And for a lot of companies will have different problems, and some people will have a problem with the volumes of data, right? They will reach the limits of their data infrastructure and the capacity to process that data, to report on that data, and they need, bigger, better machines or more optimized databases or data warehouses. So that could be a big problem. I've seen many companies struggle with the volume, but other companies struggle really with the variety, especially companies which produce vast amount of unstructured data, right? Because it's not only about data which lives in databases. It's also about maybe documents, right? Think about doctors and their, summaries of when being with a patient. They write stuff out, and these go into files, but they're not necessarily structured information. When you need to get something out of it, it's difficult, right? And many other companies struggle with velocity. They need their reporting quickly. They need something real time or near real time to improve their decision making. So I'm sorry, but there's no definitive question here. Many companies have different problems. Some companies have all these issues together.
I'm quite happy with the answer, Theo. I
Thank you.
I can take it. And indeed, guys, if you have any questions, we have a Q&A section in the chat, and at the end of the discussion, we will make sure that we will leave enough time to answer all your questions. So please, if you at any point, if you have any curiosities or if you want Theo to deep dive more into a topic, please don't hesitate to leave your questions in the chat or in the dedicated section.
Thank you, Roxana. I just want to quickly outline a landscape that is often overwhelming, because I've used the word overwhelming earlier. And this is overwhelming for us data engineers, data architects as well, because managing data is a complex topic, and it requires specialized tools and skills. And these are some of the tools and some of the skills and some of the processes that we have to manage in order to get from the sources of the data to reports that you can actually act on. One way of doing this processing, and this is kind of a history. We go down the history and the memory lane because for many years now, people have used traditional ways of creating data warehouses and data marts. And many years we have worked according to this paradigm that we cannot work with data without structure. For us, extracting something meaningful from it, we need the structure. The point I'm trying to make here is when the structure happens. Structure also means in the data world, it means a schema. In the data engineering world, what you see here in this picture is called a schema on write, which means essentially that in order, before you actually extract and save the data, you need to discuss with the business stakeholders, and you need to define the structure and the schema of the data before you start saving it and then later analyzing it. So this is the more traditional way of doing things. Now, the more recent developments have shown us another way of doing it using a data lake. And the benefits of using a data lake is that you're gaining flexibility. Schema on read is this flexibility. So you can just quickly offload the data into a data lake. You don't have to manage the schema when you write. This is the problem that you defer for later when you actually read the data, when you use it. And this tackles the three big data problems: the volume, the velocity, and variety, because data is coming at a fast pace, but you can quickly push it into the data lake. Data is coming in a wide variety. Again, you can quickly push it without too much thought on the schema. The most common complaint, however, about data lakes is that they can become data swamps if no proper data governance is in place. So while suitable for storing data, data lakes often lack some critical features. They don't support transactions, they don't enforce data quality, their lack of consistency and isolation means it's almost impossible to mix appends and reads, batch and streaming jobs. So it has been a problem, right? Solves different problems than the data warehouse, but it comes with its own suite of issues. And this is where the Lakehouse comes in. And just quickly summing up the schema on write versus schema on read. So schema on write is usually the traditional BI, right? And I like to use analogies. Imagine having to precisely define every detail of your house before construction even begins, right? Making changes afterward is time consuming, and schema on write is just as rigid. First, the schema is defined and agreed upon with all stakeholders, and this process takes a lot of time. And then schema on read, the data lakes, think about the house analogy. How about simply packing everything you own into a storage room and only later deciding what exactly to do with it, how you arrange your house? So that's schema on read. And this offers precisely this flexibility of storing the data quickly and easily and postponing the discussion about how to use it later. And this is where the Lakehouse comes in. We talked about data warehouses, we talked about data lakes, and more recently, what has appeared, and Databricks has coined this term, the Lakehouse, is this common approach to use. A lot of people I still see companies use multiple systems. They have a data lake that caters to the needs of exploratory data analysis and maybe data science teams. But they also have a separate data warehouse that caters to the needs of the BI teams and the reporting sides of things. So requiring specialized systems, also for streaming and other things, requires multiple maintenance efforts, right? Is this familiar? to the people in the audience. I'm actually curious. You can write in the chat and you can leave your thoughts there, maybe questions for later. Um, the benefits of the lake house and why this has come mainstream now is that as new systems become to emerge, um, these address the limitations of the data lakes. A lake house is an open architecture that combines the best elements of data lakes and data warehouses together. And lakehouses enable a new system design, implementing similar data structures and data management features to those in the data warehouse, but directly on top of low-cost cloud storage in open formats. Data warehouses traditionally are money hungry, require specialized databases, storage cost is high, and compute costs are high, and building, you know, being able to push your data into cheap storage and make use of that is huge. The lakehouse builds on top of the existing data lakes and their cheap storage, and these data lakes usually contain more than 90% of the data in the enterprise. Some of the features that lakehouses enable are transaction support that I mentioned earlier that data lakes lacked. They do schema enforcement and data governance. Uh, they enable this decoupling of storage and compute. So you push data into cheap storage, um, and you can then use open file formats. You can use the Parquet file system. You can use the Delta Lakes and the or Apache Iceberg table formats, and then you can choose your own compute, which can run on Delta Lake, it can run on top of Apache Iceberg, it can run on these open file formats and open table formats, and you can choose your runtime. It can be Databricks, it can be Snowflake, it can be something else. This empowers really flexibility. Support also for diverse data types, right? From ranging from, as you've seen in the picture, unstructured and structured data. Data lakehouses enable that as well. And it supports and caters to the diverse needs, the diverse workloads, as you can see on the right-hand side. It caters to the needs for the business intelligence teams, enabling using BI tools and traditional SQL-based tools and analytics directly on the source data. This reduces latency and cost by keeping the two copies usually, right? If you had the data lake in a data warehouse, you would have to keep two copies of the data. And then it caters to the needs of the AI and machine learning side, right? It caters to the needs of data scientists and machine learning workloads, and also to the end-to-end streaming, right? Real-time reports are the norm in many enterprises, and support for streaming eliminates this need for separate systems. Um, Back in 2024, Confluent announced TableFlow. This is another interesting aspect, which enables materializing Apache Kafka topics in the world of streaming as Apache Iceberg tables. So think about querying a Kafka topic, right? An unbounded stream as a table, but also the other way around. Tables are more recently used as a sharing primitive in the data world. Instead of, you know, uh, extracting and zipping JSON files and pushing them over the fence, we use tables as the sharing primitive between systems. And also more recently, at the beginning of this year, Databricks joined forces with Confluent, the company behind Kafka, and they did a partnership, a bidirectional flow between Confluent and Databricks. Think about it like this: Kafka topics appearing as delta tables in Databricks, so you can query these delta tables which have streams behind them as tables, and also delta tables appearing as Kafka topics in Confluent. This is simply amazing, and the things are moving in such a rapid pace that a lot of these partnerships are happening right now.
Theo,
Yes,
I'm nosy again.
sure.
Uh,
Okay.
you mentioned that Databricks coined the term lakehouse.
Yes.
But if a company already uses Azure, like in an extensive manner, how should they decide between, for example, Synapse, Fabric, Databricks, or other systems when they are building their lakehouse?
That's that's a good question, and the answer often depends on um, the strategy, the data strategy that the company has, the long-term goals of the company, and also the skill set of people within the company. So we've worked with customers in the past year or so that had this particular question. They came to us and asked us, you know, I want to move, my data warehouse, which sits in technology X, and I want to move it to either Databricks or Fabric in the Azure world. What should I use? And we made a pros and cons comparison of them. There's no silver bullet. They're both very good platforms, but um, we had to do these pros and cons and ask them the questions. Do you have this kind of skill set, right? Which Databricks needs? Do you have this kind of skill set which the Fabric world needs? And depending on the volumes of data and the audience and the low latency that they need and the skill set that they have, you would weigh more towards a platform or the other. So again, the the answer to the question, it depends. And
It
every
all.
use case, yeah, every use case has to be taken one by one and discussed.
Mhm. So basically, it's like an assessment that.
Yes, exactly. Yeah, yeah. I would call it an assessment. You have to do an assessment either internally or with the help of an external company, which doesn't, which thinks out of the box and is not confined by, the things within your company. And yeah, find a middle ground, find the best technology suited for you. And I go back to, I think it was slide number 6. Remember that huge
Yeah.
picture with all of these tools? That's a problem for companies right now, deciding on the technology, right? And betting on the technology and betting on that technology for years to come, because you don't want to hear 2, 3, 4 years from now, companies say, we're decommissioning this tech. Now you have to migrate. So that's a problem.
So choose wisely.
Choose wisely, yeah.
Thank you,
All
Theo.
right. Yeah, you're welcome. And one example of a recent big tech company adopting this lakehouse architecture, the Databricks world, is SAP. And you've probably heard of this, but SAP has brought into the fold the business data cloud. And they partner with Databricks and they have their own version, SAP Databricks, behind the scenes. And this opens up a whole realm of new possibilities. This is a start of a new era of data and the AI, unifying and governing all of the SAP data, but also external data. So this is not only tied to the SAP data. What they're bringing is all of the connectors that live within Databricks and the possibility to connect also other data, I don't know, Salesforce data or your CRM, in your other technologies that you have into SAP. So you're not confined also by the data that lives uh, in SAP, but also you can take data from other systems. And this is a recent example of big tech adopting Databricks after the likes of Microsoft, Amazon, and Google, which have already integrated Databricks into their cloud for quite some time now. Let's see now how this is used to turn raw data into business fuel. So platforms like Databricks and SAP Business Data Cloud provide the tools, the frameworks, and the patterns. And they can take that raw data, that oil, and refine it into something meaningful, into actionable insights. But data and AI isn't just a plaything for tech enthusiasts, right? It's a transformative tool for businesses. And in this day of age, in this time where data is abundant, right? We're producing more data than ever before. Actionable insights are scarce. Remember the needle in the haystack analogy earlier. So optimizing your data strategy is essential. And I want to also focus a little bit more on this refinery process with a real world case study and why the close relationship between data and AI and why a lakehouse architecture was the answer. And this is one of our project references. This is a customer that we have worked with, and some information about the customer, right? They're a global company. They operate in many countries. They have many stores. They have many suppliers, and they have many employees, right? And at the time when we started years ago working with them, they had, the traditional problem, let's build an enterprise data warehouse at the time. And we had to cater to the needs of top management and also all other departments within the company, like finance and other departments. And we wanted to build this single source of truth, right, for the entire organization, because a lot of companies were struggling with data marts, disconnected data marts, each with their own topic, each with their own silos. Remember the silos? But many companies were trying to build this truly enterprise data warehouse. This is one of these companies. And the need for interactive dashboards, but also the need for paginated reports delivered via email. So, and also the need for high availability with minimum downtime. Of course, challenging, right? Also managing different stakeholders and different expectations. And we had to work through that. And while we went through multiple stages and we created a more traditional data warehouse, we later moved towards the lakehouse type of architecture. And we found that this was the way to integrate all of the different data systems. They had over 30 different data systems, different platforms that we needed to extract data from. Some with structured data, some with unstructured data, right? Think about the volume and the variety problem. Also, different types of data from streaming to batch, right? Velocity was an issue as well. And also, we needed to cater to the needs of the BI team and all of those, paginated reports and live dashboards, but also to the needs of creating AI-based and machine learning-based products to catering to the needs of the data science team. And this was at the time, and actually more recently, I think it was quoted as the third largest data warehouse or lake house in the retail space. So it had to do with billions of records and also many, many queries and many active daily users. And this is an example where all of these, the solution for all of this and the best way to do it, and the choice was to use the Lakehouse architecture and Databricks. This was also an example of how such a team and what kind of skills you have to have in order for you to work on such a project, right? You have to have a diverse team of people with data warehouse experience, with data modeling experience. You have to have solution architects, SQL developers, ETL developers. Usually, it's a big endeavor to start working on something like this. And I like the picture on the right-hand side. A lot of times, the problems and the solutions in this data space is finding that sweet spot between building a compelling narrative, working with data, and creating the right visuals to support that narrative. Uh, it, it helps a lot having people with the right skills. And before we wrap this up, I want to close the loop by coming back to AI. And we discussed about the various problems with data and the solutions and why we think the Lakehouse is one of the best architectures, data architectures at the moment, and why we recommend it. And you've seen big tech companies use it. And these are some of the AI use cases that are enabled by having the proper data strategy and the proper data architecture in place. Things like, transforming just regular data into insights, but also enhancing decision making, distilling larger data sets of data into clear, actionable recommendation, doing personalized customer experience, improving operations and their processes and operational tasks, I don't know, like inventory management, scheduling, even basic customer service. These take time and significant chunk of your team's time. And then there's quality, content quality and relevance, right? We need to monitor user engagement metrics. A lot of companies want to do that. How are users interacting with your products? You want feedback, you want external indicators to tune the quality and how relevant the content or your service is in real time if possible. You want to also identify data quality issues and anomalies, right? Identify inconsistencies, outliers, errors, either correct them or flag them. Detect fraudulent transactions in banking is an example. Also, overcoming inaccessibility by removing barriers of language, right? Or physical capabilities, making your business more inclusive. Sentiment analysis by analyzing customer reviews on social media interactions, and even direct customer correspondence. Time series forecasting, you want to analyze historical, this is a classical one. You want to analyze historical data to predict future trends, sales, prices, website traffic, etc. Clustering and segmentation, right? We need clustering algorithms to categorize similar items or use cases together, but you need data to do all of this. So this is our last slide. And I want to emphasize with the picture on the right-hand side, I like tracking, I like climbing mountains. I found that this is this is the picture to close this workshop with, because a successful data strategy is the foundation of your AI strategy. But the real the let's say transforming the oil that we started with at the beginning, the oil of raw data into the fuel of actionable insights, is a journey, not a destination. You need the right skills, you need the right partners to do it. So, and each journey for change is different. It's your roadmap. You have to create your own roadmap. You have to align AI with your business goals, prepare your data, implement AI solutions, measure their impact. AI is a powerful thing, but it comes with its own set of ethical and operational challenges. So be prepared. And you don't have to figure it all out at the start. Start with a pilot program. AI and its applications are constantly evolving, and you need to stay updated, adapt, and refine your strategy. Yeah, let's all keep our journey to the top, right? And this is a journey, remember, not a destination. And we're in this together. Thank you.
Thank you so much, Theo. I'm so happy that I cheated a bit and I took a look in the Q&A session, I must
Oh,
admit.
no.
And I saw some very interesting questions, and I'm really curious to see your answers. But before that, for the people that are attending today, please just take one more minute at the end to fill in the feedback form. This really helps us adjust and improve the webinars for the better in the future. And I promise it just take 1 minute. Good.
Remember the feedback that I mentioned earlier, right? We also need feedback.
We are huge feedback lovers. So the questions now, and I will start with Florin, who's asking what happens or goes wrong when organizations try AI without excelling at data basics like governance and integration.
Oh.
Oh, oh.
Oh, yeah. I've seen companies attempt that. Even I've worked for companies that try to do that. And, there's all of this hype and people just want to get quickly started, and they hire data scientists and then they throw them into the pit and they say, come on, build a data, an AI product for us. And then what I usually find is that these data scientists start doing data engineering work, and they have a lot, instead of doing what they're good at, right? Making experiments, creating models and featureization and actually doing something that they're good at, they have to spend time cleaning up messy data. You don't want to get there, right? And also I've seen problems with not only wasting data scientists teams, but also having to go through all of that cleansing and structure and structuring the structured data to even start and begin with a data science project. So while you think you're working on a data science project, you're actually beginning your data journey. And yeah, you need to clearly define these two, and yeah, where the ball, is passed from one team to another. I hope that answers the question. So yeah, there's a risk there if you don't have a proper data strategy in place.
Indeed, and we always say start with data. As there's no literally there's no AI without data. So it's of utmost importance to make sure that your data is in place before starting to look into how you can leverage AI, because otherwise it will just not create the business
Yeah,
that the company needs.
exactly. Sure, you can have your eyes on the ball and the long-term goal of creating AI products, but always be mindful and try to do it the right way. Don't take
Exactly.
shortcuts.
It will cost you in the future. Great. And Marush is curious about Databricks, and he's asking if I'm a company looking to adopt the Databricks Lakehouse, where should I start? What are the first steps I should take from a technical and business perspective? And do I actually need to migrate all my data to Databricks to start using it effectively, or is there a way to integrate with existing storage and systems?
That's a good question. It's Databricks has, and many other platforms out there, like even Snowflake and others, and even Fabric in Microsoft's world. They come with their own, academies. You can sign up for this academy and you can have your people trained, even though you don't operate in the data field. Maybe you don't want to make a business out of that, but still, as a company, as a business, you need to know what you're getting into. So I would say sign up for these courses. You have also courses for management, you have courses for data engineers, you have courses for a lot of people. They have these good academies. Of course, if you don't want to do it yourself, find a partner. Find a Databricks partner that you can partner up with, and they can do all of these. We've seen, and we can actually do ourselves even these kind of courses for companies, and get them up to speed on what Databricks is, what a lakehouse architecture is. And like I said before, companies asking, should I use this or should I use that? For instance, Fabric in the Microsoft world is also built internally on some technology from Databricks, like the Spark engine. And what they usually do, and Fabric emphasizes this, that they enable you to connect to different data sets and virtualize these into one single data lake or data lake house, even though they live in different silos, but it looks like they're in the same data lake. Also, Databricks has different types of connectors that you can use to connect and build your data lake on top of existing data lakes. Remember, you're building something on top of cheap storage, cloud blob storage, right? And this is the cheapest you can go. If you're trying to build your own data center, it'll cost you more with all of the investments into hard drives, solid state disks, and write arrays and whatever. Um, I'm actually passionate about that side of things as well, building my own home lab and such. So um, it costs you a ton of money to do that. So right now, generic blob storage is the cheapest you can go with. And lakehouses like the Databricks platform enable you to build on top of this cheap storage.
I will just continue with Alexei question because I think it builds nicely with what you just said. And then I
Sure.
promise I will go back to the question section. Alexei is asking, what do you think about building Lakehouse on an open source technology?
Lakehouse and an open source technology. I think it can work. I mean, think about Lakehouse as a methodology, as an architecture, as a pattern. You don't have to use the Databricks or the Snowflakes or whatever. You can use open source technologies, yes. And this is the beautiful part of these open file formats, like the Parquets, the icebergs, um, the Delta Lake format, and other file formats. They enable you to build on top of this cheap storage And we also have to keep in mind the data catalogs that we need to put on top of these open file formats. And we have a bunch to choose from, even in the data open source world. So you can build all of this. Remember, decoupling storage from compute. And you can even swap providers or swap your compute side of things, right? You build all of these your data on top of cheap storage and using open file formats, and then you can try different technologies for the compute side of things. And you build these virtual data warehouses or virtual lake houses. So it definitely can work. Of course, you need more time, you need more skill, you need to sometimes stitch things together to make it work. That's why a platform like Databricks often comes with a lot of built-in things, and it can get you up to speed faster. But you can definitely do it with open source technology. Yeah, you're not limited to
Oh,
Databricks.
hope this answers. Yeah. Then we have another question. Could you give us a simple example, illustrating the difference between schema on read and schema on write, and how the Lakehouse balances structures and flexibility?
Okay, schema and read. Oh, well, I would go back to my analogy with thinking about how exactly how you want your house, right? Before you even start laying a single brick, right? You have to have all of the schematics and everything in place before you start. That's the problem with schema on write. Before you start writing, before you start doing anything, you need to, and this often needs discussions across departmental silos and um, finding a common ground and finding the right answer. And what are you trying to report on? We have to understand what they're trying to report on so that we can understand how to model the data and the schema which the data will sit on, as opposed to the schema on read things, where, again, going back to my analogy, right, you can have a warehouse. I won't use the word warehouse. You can have a closet full of stuff, and you have your empty house, and now you can start thinking about how to arrange it, right? But so you just quickly offload the data as quickly as possible in its native format, right? No transformations. And then you start analyzing it, you start using it. But again, be careful about building data swamps. This is where the medallion architecture of the lakehouse comes into play. You have the the landing zone, or the bronze layer, you have the silver layer, you have the gold layer, and each layer brings more and more um, processing, more and more business rules, and more structure. I hope
Thank you.
that answers the question.
Thank you, Theo. If not, please, guys, just write the follow-up questions in the chat and we will make sure that we will come back to you with more details. How does the Databricks Lakehouse and its medallion layers, bronze, silver, gold, specifically prevent data lakes from becoming data swamps and ensure data quality?
Um, I think it ties to what I was the point I was trying to make in the earlier question. Each layer in the medallion architecture, and you can have 3 layers, you can have 4, you can have 5, brings additional structure. But you don't have to think about the whole structure from the beginning, right? You start and build like Lego blocks on top of your raw data, and you can even have the different same data but different models of it. You can model a classical star schema model on the one hand side, but you can model a data vault type of architecture on the other side, and these could cater to the needs of two different needs, but they're all built on the same underlying raw data. And that's the good thing about the schema and read approach in having all of these layers, because you can quickly build another model on top of your data. You don't have to extract it all over again. That's what we had to do in the past when we worked with data warehouses. You want something else now? I need to collapse everything and extract everything again and build it all. Now you just have that raw data living in your raw layer, and now you can play with it and model it in different ways until you find the right way for a particular use case.
I just love the next one. And
Okay.
Yeah, because it's such an important source of learning. Can you share some common mistakes company make when implementing Lakehouse architecture?
Common mistakes that companies make. Well, that's hard to answer because the Lakehouse architecture is kind of new. Well, not that new anymore. So not a lot of companies can say, "Hey, I've successfully built a Lakehouse architecture."
Yet.
Uh, Yet, yes. Although we have seen companies do it and helped companies achieve that. But common problems with building it is, again, problem is extracting data. Even in this day of age, extracting data is a problem. And even if you land it quickly in the raw layer or the bronze layer, you still have problems with source systems because there's this keyword from extract, transform, and load. Extract. We extract data. That means we invasively take data from systems, right? Sometimes without even their knowledge, right? Well, of course, they give us access to their database system so we can extract to it, but they don't necessarily know what we're going to do with it. And when they change their structure, our flows collapse, and we have to be ready to fix these things up. So one common problem that I've seen in building lakehouses is still the ingestion side of things, bringing data into the lakehouse. First things first, right? You first need to land that data in order for you to start consuming it. And that's why a lot of companies in the more recent side of things, people are trying to build what are called data products. So instead of us extracting data from source systems, we should consume data from source system, but we should do that by having the data team talk to the application team and discuss about this integration instead of the data application team just, here are the database credentials, have fun, right? I think it's still the main problem even these days in all architectures, really.
Thank you, Gio. And we have just one more question, and then we
Okay.
will wrap it up. From Alexei, what do you think about what model is better for banks?
Okay, better for banks. That that's a tricky question because even in banks, there are many use cases, like and um, the classical star schema can be a very good use case for, I don't know, analyzing just transactions, how many transactions, the volumes of transactions, and so on. You know, you can quickly model it, you can quickly put it into a Power BI model, uh, and then start reporting on it. But there are more, I don't know, credit loan approving a credit loan, and this requires a different model. Like the fact table is no longer a transactional fact table, is an accumulating snapshot type of fact table where one row is a credit loan approval, and you have all of these stages within the loan process that you need to update, and then you want to report on how many loans do I have in this stage, how many loans do I have in this stage, what are the sums and the values. This so requires a different, depending on the use case, right? You might want to model a classical star schema with a transactional fact table. You want to model the accumulating snapshot, or maybe you want to model it using the data vault architecture, which enables you to quickly, if you have many changes in the source systems, it allows you to quickly disconnect old source systems, connect with new source system, and seamlessly make them available to the reporting side of things. It really depends.
It seems like everything depends. And that's
Everything depends. In the data world, everything depends. Yeah. And you have this all of these technologies and tools at your disposal. And it's not like, I don't have something to work with. No, we have a lot of things to work with. A lot of times it's all about choosing the right tech, choosing the right skills, choosing the right modeling techniques
well,
that requires expertise.
that's both a blessing and a curse. And I really believe that this is where a partner can help you make the best decisions for your company and for your ecosystem. because as Theo mentioned, it really depends on the current systems, on the skill set that you have in-house, and of course on the business goals for the long term. So basically having that North Stars that guides the whole data strategy and what do you expect from AI. Good. And that brings us to the end of our session today. Thank you so much for everyone who joined us. And we hope that we brought you some valuable insights into how to build a data lake architecture. And keep your eyes on the mail for next week as we will announce the winners. And hopefully, we'll see each other during our next webinar in June. And yeah, that's it. Thank you so much, Theo.
Keep your eyes on the prize, right?
Of course, always.